Hello everybody, how's it going? Sorry that it took me a little bit longer to start the stream when I've actually been on time consistently. I was like a little bit annoyed because I don't have the lights that I used to use for filming anymore, so I've been annoyed with like the lighting of the stream. So I have like one of my old box lights, and like it looks too bright and I can't get it to like look right. So I'm like, no, we'll just do dark. We'll just do dark instead. So I've been fumbling around with lights instead of streaming. But it's fine. So, to catch you up with what's been going on stream. I've been working on there we go. I've been working on a not sandboxed. I just fell right back into the brain script pitch. We're not working on brain script. We are working on a multi-stage programming method, basically, on testing that out. So in the first one of these streams, I thought I was going to use Lua, and then I decided, no, I don't like you, Lua. We're gonna use a custom language because I can't find any dynamically typed scripting languages that I actually like. So we just made our own. And then the second stream, we worked on getting that first version that we got working in the first stream. We got that working. I think I worked mostly on a parser. I don't know if we actually got it running by the end of that stream or not. But since then, we do have the scripting language running. So if I do Argo run test pillar, and first we can see this is all the operations getting written. I believe this is our actual script right here. Now there's two other functions that actually get generated, because this is an inline function definition and this is also an inline function definition, and those aren't showing up in what I actually print out here. So this isn't the entire program, it's just that first function. But then here's some debug logging for the rest, for like when we actually run it. And then this returns 5. So if you look at the actual program, we have 2 and 3, which is A and B. Oh no. I don't have my camera plugged in. 1 second. I just have like a camcorder hooked up with an HDMI capture. But the really annoying thing is that when it's just on battery, when the camcorder is just on battery, it likes turning off if it's not actively recording, even though I am actively recording. I'm recording just not with the camcorder. I'm using its HDMI preview to record, but it doesn't think that that's actually recording. So I need to go here and turn off by plugging it in. Go. Now let me make sure the stream is fixed. Okay, good. We are still getting video. Alright, yeah. So you can see very convoluted. I'm just trying to test out make sure everything is actually working. So we have 2 and 3 stored in A and B. We make f equal a function that calls the global add function. So this is something I've started doing for languages I write, is not giving them operators, because there's a lot of interesting parsing stuff you have to do to get math operations to correctly parse. With like operator precedence and whatnot, like multiplication should happen before addition and all of that stuff. And there's fun parsing stuff you have to do to make that actually work. That I don't want to have to do because I want to just like have a language that works, and I don't want to write a complicated parser with a parsing library. So we're just keeping this like really simple at first, no operators, except for the call operator and some base level required grammar, which I think we have all of our base level required grammar, except for some form of looping and some form of branching. Which I believe the only form of looping that we actually need is a while loop, and the only form of branching we need is like a match statement. So those, if you haven't noticed, I just jump into these streams without actually planning. So let's make a plan. So things I still need: branching, which for now is going to be a match. And then we need looping, which a while loop takes care of all of our needs, just all of them. So the ability to match, now, will we have pattern matching? I don't know. Always coding a neural network that then train the code for that. That would be convoluted. Yes, that would be convoluted. If I had enough training data, it would be possible. Yeah. So we need these. What's the other stuff I need? I need to fully implement. So right now, this function right here, when we actually initialize this closure, so closures that capture variables from the outside environment, those are called, lambdas, which is an inline function definition, is called a lambda. When those capture variables, they become a closure. So these are closures. Here we can see it's accessing C. C is defined right here in this scope. Now let's say theoretically we set C to something else right here. Like if we said C is equal to 2, this is after our function definition. So we would want this to, like, we want this to no longer, we would want this C to still reference this object, not the number 2. Currently, with how I've implemented it, we just define the function definition here, but then when we run the function here, it just would read C from the environment where we called the function from. But we don't want it to read 2. Right now, this would try to access member C of 2, and that wouldn't work. In fact, let me just directly show that off. Now, it's probably not... Did I write it? There we go. Yeah, so this just straight up isn't working because I didn't actually I haven't defined assignment operations yet. Which is important. I need to do that. So actually, so we need to reassign existing variables. This is probably right after the closure variable capturing it. So if instead I just redefine C, this will do the same thing as setting C, but we're going to ignore that for now. Anyways, so now it's going to fail because expected I wrote it with a semicolon. I don't mean expecting a semicolon. There we go. I just hadn't saved it. So here, you can see it failed to run because it expected an object but found an integer. So that's because this didn't copy the variable c when this closure was created, so it's just referencing the c that I redefined down here. And that's obviously not how we want this to work. We want this to still work if the variables are changed afterwards. Or rather, labels of the variables changed. We would want changes in this object that is referencing to still work. We wouldn't want like a deep copy of the object. We just want a shallow copy of the object. Anyways, so we need to actually implement closure variable capturing. We need reassignment of existing variables, so the ability to just do this. And the reason why we need to be able to do that is, let's say we wanted to reassign c dot d like this. This wouldn't work, and that's a lot more concerning than not being able to, like, because right now we can just cheese it by getting around, we can just cheese this with let statements for global global scope variables. Yeah. So we need to do that, and we need branching with things like a match statement. I think we might not need... I want to make while loops well, I mean, they are an expression. We would just do a none value from them. Something I learned recently is Rust actually lets you return values from loops. I don't know if it lets you return them from while loops, but it does let... Rust has a loop. This is just a straight up loop. And the only way to get out of that loop is through break statements. So it lets you return values from break statements, which is very interesting. I don't think I want to support that, though, because it feels... While I don't see too many bugs that could happen through being able to return from just straight up loop statements, I'm just not going to have loop statements and while loops. Then you get into like did you break from the loop statement with a return value, or did the condition just fail, so we exited out of the loop? Or yeah, there's lots of weird stuff with that. So we're just going to have while loops. Won't stop being funny that after all this talk of making sure your code is reliable and doesn't fall silently, and so on, then AI comes along and just violates all of that due to hallucinations. But you see, we must AI. We must use the AI because it is cheaper. Fun fact, AI isn't actually cheaper than human workers at this point. Human workers are still more efficient, and people are going to figure that out eventually, and that's when the bubble bursts. It was when you realize, oh, it's just a tool that could help existing humans. I shouldn't have fired everybody. Okay. What's feeling weird is my voice feels slightly burnt right now, but I haven't been talking a ton. But what has occurred is I was working a ton on my car yesterday. I was swapping my valve body, which seems like it actually fixed my car. I don't have slipping gears anymore. Anyways, but like I was under the car and like keeping my head up, so like my neck is super sore. I'm wondering if that's affecting my vocal cords right now, which is super weird. Anyways, okay. Let's see. Actually, the reassign existing variables, this is maybe the easy one. Maybe. Possibly. So the interesting thing about assignments like this, like assigning a variable, is that there's concepts in programming called L values and R values, and what that really means is temporary values versus values with addresses. And in this case, the way that my parser is currently working, we would just have the value D, and then assigning to D doesn't work because we actually don't know where D exists. We just have the value of D. So this member access pattern here is effectively the path to where this variable is stored. And what we need to do is, let's say we had like a super deep path to a variable here. We would need to actually like get member, get member, get member, get member. But then this one right here, we don't want to get member D. We want to set member D to 2. So there's a different command that runs. We want to omit right there. So I actually don't know if it's simpler to do that. And then for captured variables, we basically need to make our parser smart and go, okay, has this variable been defined within the local scope of the function? Yes? Okay, then we don't capture it. If it's defined outside of the local scope of the function, then we need to define in the function definition, or define in the function definition that it requires the capturing of a variable from the, not global scope, but local scope of like wherever the function gets, or wherever a closure gets instantiated from that function definition. We need to give it a list of like which variables to capture, and then expose to the function body when it runs. So both of these require modifications to the parser, and I'm not sure which one's harder. This one might actually be a little bit harder. I'm not sure. But yeah. My siblings are being very loud. I just realized I'm not playing any music. Let me fix this. That's why I can hear my siblings so much. Okay, they're not shaking my door. They're shaking the door right next to my door. That's why the vibe was wrong. The vibe was wrong because no music. There we go. Your siblings come for the plunger yet? No. So the plunger didn't get put back in my room. So it's now accessible without running into here. Also, hello as well. Okay. So yeah, this is okay. There is one other thing I need to add. Implement array types. So once we've implemented array types, once we've implemented array types, then we will actually be able to whatchamacallit. Then I think we will have enough of a language to start implementing the actual emitter for C after we have all of these things. by creating a standard library for ourselves. And then making that standard library be able to emit, that standard library will be able to emit, work with me here, brain. We'll just be able to emit C, basically, through just our regular expressions. Hopefully. We will see. And we will see. By which I mean the letter C, as in the programming language. We will see. I think the assigning existing variables is that one's my priority first, because I want to be able to set variables. And also it is some parser stuff, so we need to work in the area of the virtual machine. We need to go to parse. In here, when we I think about how I've been writing my grammar. So the way that I've been writing the grammar is that basically I don't have to do... There's something that parsers do sometimes, which actually very commonly, they do this a lot, which is they have several different types of, several different branches of grammar that they could parse for any given, like, set of symbols, and they'll go and try to parse through an entire, let's say, like, a good example might be the difference between a scope and an object. And this is the reason why I have this little object, like you have to say obj before defining an object here, is that obj tells me, hey, right here, this is an object definition. This isn't just like, I could just do this, but then run code inside of here, and then that scopes the variables. And that functionality should work. I haven't actually tested it, and I don't want to test it because if it's not working, that gives me another to-do list item, and I don't want more of those right now. But, like, how does my parser tell the difference between those two? And in the case of my parser, it's because I put something before it. So if this is an object, that will always be this. If there wasn't object before it, that means it's like an expression. It's a scoped expression that could have a return value. So for instance, I can probably do this, and then the code would still run and execute fine. It's just a scoped expression that can have multiple lines, with the last line being the return value if it has no semicolon. That's a concept I got from Rust that I really like. Being able to scope a bunch of things to assigning a variable, basically. Because the alternative to that functionality is to define a closure and then immediately call it, and that's more work than we need to do, as both when writing code and when executing code. So we just have that expression thing. Anyways, back to the point I was making about parsers. It's like when you have two ambiguous statements, and the way to solve which statement is which would literally just be to, like, try to parse one. If the parsing fails, try to parse the other. And then if that one succeeds parsing, then that was the expression that it actually was. Now, the problem with that is you have to have, like, a rollback system. So you have to have a way to catch the failure and then retry a different way. Which means I can't do what I'm doing in my current parser of just, like, immediately pushing expressions. And now that I'm thinking about it, there are ways that I could, like, if we store the index of the current amount of operations we had, and we could just delete the operations that we tried to write while parsing the other thing, that would make make it so we could try to parse one grammar, fail, and then try to parse a different grammar. But I don't want to do that because I kind of like the idea of my parser being simple enough that I can just write it by hand in a single pass, because I think that will make the parser really efficient, because I want this language to compile and run really quickly, because it's an added cost on top of generating C and then compiling that C and then running that C, and I want to have a really fast iteration loop if I do write stuff with this system. Like, to the point of, like, I want to be able to make a change in my code, save, have something watching the files to see if they've changed, fire off a recompilation that compiles a DLL, and then I have my program load that DLL. Basically hot reloading, and I want the hot reloading to happen in like under a second. Like, I want to click save the changes over there, like as soon as my eyes move over. That's what I want out of my custom development experience. Because, like, if you don't have a better development experience than, say, Unreal Engine, what's the point? And one of like the downsides of Unreal Engine is that, or Unity, both of them, is that it takes a really long time to compile when your project gets big. So then, like, the thing that I used to do on, like, Unity projects when I was testing out physics stuff, of just, like, couple character code change, recompile, couple character code change, recompile, test, 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 see what feels good. Does it feel better this way? Does it feel better that way? Like, the only way you make good things in game development is by just retesting over and over again. Both you testing and then having, like, testers play your game and then play it. It's all testing. There's no you build it right the first time. You have to build it over and over again and iterate. It's all iteration. And it's not just game dev. That's how you make anything good. That's how you learn skills. That's how the world works. So when your iteration time is slow, that means you are slow. Like, the thing can't get good quickly. And yes, there is, like, static validation tells you if it's good before you even write it. But if you think about it, that's a form of iteration time. If you have, like, an LSP telling you, like, is your code good, is your code bad, that is, like, a form of, that's a feedback loop. The smaller and tighter you can get the feedback loops, the better. Anyways, all that to say, I want this to be fast. I want the code that gets emitted to be fast. I want the code that I'm writing to be written fast. I want everything to be faster. To be fair, I think it takes a bit less time to rebuild if you use a supported editor. Like Unreal Engine? I'm not using Unreal Engine with Vim. I am using it with, like, the supported toolchain. I just mean it is generally slow to, like, redo stuff. When I work with a game engine I don't use Vim. I like put Vim key bindings on a like VS Code with Unity. No, that's what I did. Like, back when I was working with Unity a ton, and even, like, yeah, I would always use Visual Studio with Unity. Like, the compile times are too long. Especially when your project gets bigger and you have, like, libraries start adding in their own, like, checks they do on the code base and whatnot. Like, Unity gets bloated. Unreal Engine is just a C++ compiler. Iteration times aren't good enough for me. Like, that's one of the reasons I want to do this. It is slow even when the project is large, yes. Or small, yes. Okay. Going back to this. My whole thing of, like, we don't have whatchamacallit. We do not have work with me here, brain. we don't have the ability to try to parse things, but I don't think that's a problem. So a weird jank workaround that I did for getting function calls working is, let me get my code editor bigger here so I can show this off better. Is if you notice the call indirect takes the arguments, the argument count, and then the callable thing. So the highest thing on our stack should be this callable. Now, with the way the parser works, it kind of just goes and parses from left to right, but if it parses from left to right, that means on our stack, the callable would be the first thing. So we can't emit the code to access, like, the function. We can't emit the code to access the actual value of the callable function until after we've parsed out all of the arguments. So what that means, so the way that I worked around that, of like not emitting the instructions to actually access the stuff, was I made I basically deferred actually accessing the stuff. So instead of directly emitting operands, instead I just said access operations, and then push to this vector, and then after this, we're evaluating the atom, I just appended that to the function body. If there was leftovers, or in the case of a function, I just evaluated all of our all the arguments, we parse them here inside this loop, and then after we're done with all of that, we push our access operations and then the call operation here. So like weird stuff we have to do to make sure the arguments are in the right order. For when we call the function, we need the arguments to still be on the stack, basically, so we don't have to do any weird like juggling of arguments. No, after you call the function, the actual like function is here on the stack, that gets popped off when we call it, and then our arguments are left for the function to consume itself, like the body of the function. Now, this currently does account for the case of we have a function, it returns an object, and then we still need to access members of that object. So you can chain calls and getting members of the objects returned by those calls, and then calling stuff on those values as well. So what I need to do here is we need to be able to make a more advanced version of this access ops system here, that instead of doing what it's doing now and just kind of pushing raw operations, we need to do something more intelligent. We need a new structure for this. I think I'm going to put it underneath the parse context. We're going to call this a object member path, like this. And We're gonna have a root object member path root. And there's two types of roots that we can have. We'll have a variable, which is we need a symbol ID. But actually, we're just going to call this variable path because this could theoretically not be interacting with objects, and then this root would just be the variable. So either this root could be constructed with finding a variable, or it could be constructed with the current top of the stack variable. How do I make this work for chained function calls? I just realized that this actually doesn't work for chained function calls. How do we reconcile that? So if I'm thinking about that, if we have... Let's say that we have G, and G returns... Let's say member result, but also just the function add itself, like that. So what if we call GAB but I need a less contrived example. So we have an object function is equal to function, and this function returns object A, which object A has an add function that we just set to the global add function. Now, if we call object function, then we get A from here. We should be able to call add, right? Object function returns an object, and then we have A, and then we have add. Now, the problem with how this expression currently works is that the way that the stack should be organized to be able to call this is we would want A and B on the stack, then we would want basically add on the stack after that. But the problem is we will call object function. It doesn't have any arguments, so we don't need to worry about that. But then we would need to call get member on the output of this, meaning that we actually need to call object function after pushing A and B to the stack. So we would push A and B to the stack, we would call object function would return an object. We would need to get member A from that object. Now, this consumes the result of this, and now we have the object with the add variable on that, so we need to get member add. And then on top of the stack now is add, so our stack looks like A, B, add. Now, the problem is our parser would currently just execute object function, and then object function would be the first thing on the stack, which that doesn't really work out here. Which means I have a couple of different options. The first option is to make my parser good, is just to get good, so that it is able to defer basically the furthest function call back. The furthest function call back has its arguments pushed to the stack first, if that makes sense. Which it should. So we would need to create a data structure that's able to push arguments first of the furthest one back, basically swapping stuff. For this expression here, we would need to resolve A, B, and then we would need to push the args for the object function, and then we would need to call object function. Now, object function doesn't have any args, but let's say, for example, it took foo. So we would need to push foo to the stack here. We need to call object function, and then we would need to call we need to resolve A, and then we need to resolve add, and then we would need to call add. Like that. The first option is to make the parser get good, and this is how we would have the parser get good. The other option is to have the actual runtime account for we could have the whole call indirect take the function callable before the arguments, and then when it executes call indirect, it could read the argument count and then go back that number of arguments on the stack, remove that member from the stack, so the stack now shifts over by 1 because we've popped a value out of the middle of the stack instead of off the end of the stack. All of those shift over. We don't even... I guess we would have to put arg count back onto the stack because we just popped it to read it. Unless, well, all of this is a jank operation that doesn't follow the rules of the stack machine. Which is stupid. And then we're doing O of n operations in our actual execution of the language, just to call every single function. So if you have a function, 5 arguments, you're shifting the entire stack over by 5. And no, I kind of want we want to make the virtual machine as simple as possible so that it runs as fast as possible. So that, it doesn't need to be fast, but we want it to not be we don't want it to execute as slow as Python. We want I want to beat Python. It's not hard to beat Python, but I think doing stuff like that is how you get into the range of being as slow as Python. So, how do I do this? Instead of doing this whole variable root path, instead we need some way to construct we need to be able to construct an expression. Dang it, I don't want to have to make an AST. Does this have to be an AST? I don't know. Now I'm thinking about the example of what if we're doing an assignment operation? In the case of an assignment operation, it gets an AST, abstract syntax tree. We love Python, it's impossible to beat. Moving on. So an AST, or abstract syntax tree, is a data structure that is just a tree of all the grammatical expressions in a coding language. So this is a way for you to basically disconnect the order that your grammar is written in from the order that you need to like read that data to execute stuff, which is exactly the problem I'm running into now. It would be amazing to have an AST for what I'm doing right now, but the problem is that I'm trying to do just like a forward one pass parser, because I was like, oh yeah, I'm just going to not have an AST, I'm just going to directly emit operations. I don't... Fine, I'll make an AST. An AST solves all these problems. I don't have to do some weird deferred emitting of expressions if I just make an AST. So we're just going to make an AST. Yeah. I'm gonna do it the correct way. And so we go from... We're gonna have to go from here's our original source document to here's tokens to here's an AST to here's our intermediate representation, and then we can execute it. I always try to get out of making one of these data structures. Now, so help me, if we make HIR, I'm gonna crash out. We're not doing hot... Crap, I just realized this is the HIR. And then we're lowering it to C. This is all language development is, by the way. You transfer the language into another language, or into another representation. Then you transfer it into another representation. Then you transfer it into another representation. Then you transfer it into another representation. Actually, here, I'm kind of... You want to see how many representations your average Let's take C++ for an example. No, let's take Rust for an example. So you have the language. This is the first representation. This then gets tokenized. So then it is represented in tokens. Then it gets turned into an AST. And then this gets turned into HIR. And then this gets turned into what I think they call it MIR. And then this gets lowered to backend, or lowered to a backend, which is either LVM IR, which this is like this is CLang, like the same library. This is CLang basically, but without the front end, or CraneLift IR. And then both of these use some form of pattern matching on that intermediate representation to lower it into machine code. So, if you've ever wondered, how does a low-level language with not even low language, Rust is kind of high level that gets lowered all the way down to machine code. Actually, wait, I forgot a step. This gets lowered into ASM. So this gets lowered into assembly language, which then the assembly language goes through an assembler to actually create machine code. Am I missing anything? I mean, I guess you could... No, this gets transferred to assembly language. Assembly language, machine code object. Then you throw this into a linker, and then you get an exe of... There you go. I was trying to avoid... How much of this was I trying to avoid? I was trying to avoid... Yeah, I was trying to avoid that much of the stack. Now I'm like, okay, fine. We can add in the AST. So macros... So if you want to add macros into this, macros exist in the language. So tokens are here, and generally the way... If this is like a C... If you're doing C-style post-processing, you will run your macros and then get language out. So it's not really a different representation, it's like a transformation on it. But if you're doing Rust-style macros, macros actually run after the tokenization stage, so macros are here, but what macros output is just tokens again. So in both of those cases, it doesn't actually add another representation of code to the thing. It is a different language usually on top of the language, like it's a different grammar. So you basically have multiple languages, and those languages get tokenized and then run. What are tokens? Amazing question. Not to be confused with the tokens used by LLMs, but where did I put them? Lexer. So your code is lexed, and that turns them into tokens. So these are all my tokens. So instead of in my parser going like, oh, is this character or this character, instead what you get are tokens. So anytime I have like, here's like the blocks that make up the code, those are tokens. So here you have identifiers. So anytime like in my example code I write like let or variable name or reserved variable like for. Now like reserved variables, I could make those be tokens, but I'm kind of stealing what the Rust compiler does, which is use identifiers for everything. Because like I could just check if this identifier is for a for loop or like the word while or the word if after the fact, without adding extra extra stuff to this. Like, that's a little, like, it doesn't matter if that's at the token stage or wherever. Yeah. And then if you're talking about large language models, those are more abstract. You can have like a token that's like a word and a half, or like half of words are tokens. But it's a similar thing. Like, if you ever hear AI bros talking about tokens, it's because they are running like Elixir to break the to break sentences into chunks. So LLMs aren't literally just predicting single letters, they're actually predicting chunks of words. Anyways, my crash out about that is done. We're gonna add an AST and it's gonna make our lives easy. What abstract concepts do I have? I just realized I have the same page twice. Let's have this be the, not the Lexer. We want this to be main, where we're actually doing stuff. No, the VM. We're taking stuff out of the virtual machine. This whole like parse script and then parse expression, all of that. I do like this having a reference to the virtual machine so we can directly intern strings. Because I'm not trying to multi-thread this at the moment, which is going to bite me later, but I don't care. We're not trying to multi-thread this, because the multi-threading, we don't need multi-threading in our development environment for this MVP that I'm trying to write as fast as possible, so I can just test if I even like the idea in actual practice. Doesn't the parse context have a reference to VM? No, it doesn't. I thought I did that. Interesting. Didn't I do that? I could have sworn that there's a bunch of places where I need to put... Oh wait, is it the Lexer? No, I don't intern strings in the Lexer, so what? Which one of these things was it that I took a ton of time? Oh wait, was it execution context? Yeah, it was execution context. So when I execute, so I can actually execute operation by operation. So if I ever implement a debugger for this language, it'll actually be super easy because you have to manually call like step every single time you do an expression. So debugger will be really easy. Really easy. The architecture is already there. It will just be adding on instead of refactoring. Okay, so all of these are going to be really fun. Say public. Virtual machine reference. For our parse context, so this will be created from within the virtual machine. Parse tokens because we need to intern strings. I should probably do this for tokenizing as well. That way that we're not copying strings. Actually, we're just looking at hash lookup. It doesn't matter at the moment. Let's try not to overthink things. Heaven forbid we overthink things, right? Okay, so thinking about this, what syntax are we going to support here? We need to look at our current code base here. So we have our expressions. Refactoring is for to refine the previous overthinking. Indeed. We have our expressions of a kind. And I'm gonna make this look like the Rust parser. We have expressions, and then if I just look at my code here and ignore my schizo rant, we have let expressions, which are, these are basically pattern matching statements, pattern matching expressions, which the purpose of let statements is that, fun stuff with this. So let is a pattern match that adds variables to the local scope. That's the best way to describe what that's doing. Which, that's a Rust thing, and I basically want Rust as a scripting language, or Rust syntax for this scripting language. So we have let expressions, we have, and in Rust they would be statements, but we have scope statements, which all this is a vector of expression with an optional tail expression. But we'll define that separately. So we have let expressions, we have scope expressions. So let includes this equals, so this is not an assignment expression. So we have another let expression, but inside of here we have a closure expression. And this uses a scope expression and a return expression. And they're all expressions, they all have return values, except for return, because that, you know, yeah. But we're going to count it as an expression. So that uses a scope. We have a return expression. The return expression uses a call expression. Hello. Yeah, I've been getting back into streaming recently just for the fun of it. And then, okay. So that's all the expressions we use here. And then we have a let expression. We have an object expression. So this creates an object. I probably also want to create an array expression while I'm at it. That will just in place, like, create an array. Like, you square brackets, you get an array. Let's see. Object. Ooh. I want to define. Yeah. Okay. So here, and here, what I missed. Oh, I actually did miss something really important here on this let expression. We actually want constant expressions, or I guess literals. Which these can just be IR. Constants, I guess. Oh wait, I don't want this to be IR at this point. I think I want this to be Lexer. Want this to be a literal? Yeah. We're gonna do an IR constant. This gets us closer to the eventual, like, end outcome that we actually want. We have literals. It's literally just that expression. What language is this? So on the left, this is Rust, and on the right is a new language that we're writing right at this moment that basically has, it's Rust syntax, but it's going to execute very similarly to Lua, with the one change from Lua that I want to have objects and arrays be different objects or different types, because I don't want to have to do the fancy things that Lua does to make that actually efficient, having just tables. So basically it's I want to use Lua, but I don't necessarily like the way Lua does everything, so I'm making my own version of it, is the TLDR of that. So Rust into our own thing that looks like Rust but acts like Lua. Okay, so we have literals, and then we also have variable. Technically, if this was the Rust parser, which, yes, I've taken the time to look at the Rust parser and figure out how it works. At least it's AST. These would be called paths. These things here, like thing.thing.thing, a thing, all that thing. All of that. This is a path. This is technically a path. This is also a path. wonder... wonder how we handle calls with this grammar, because I want to make the entire point of this AST is to make it possible for us to easily handle operator precedence, basically. So how do we handle the fact that our arguments must be evaluated before this, but the problem is we can't evaluate this and then like this portion of this. We need to evaluate this and then all of this needs to be like the furthest branch first. So I'm thinking about how we're going to be walking over the AST. What would the AST look like in this instance? Is this entire bit a path here? Oh, but not quite Lua. Lua ain't. No, we're calling it pillar. I just like the idea that eventually I can turn this into my perfect language. So it can be like the pillar of my dev environment. It's also a JoJo reference to perfection. Is this a path expression? I know that this is a path expression. Then we get a call expression. And then is this call the root of another path expression? It almost has to be, doesn't it? So then we have another call expression here. Now, what's really fun is what if we had something like this? Ignore the names of the functions. Let's say this is bar. And then we need member A of this, and we're setting this to 2. Or even better, another call. So we have to evaluate all of this so that we have a value to set a member to. Or like, yeah. So this bit here gets turned into an object. This label is directly pushed onto the stack. Like A is pushed onto the stack so that we're telling the virtual machine to set the A member of that object to the result of this expression here. So this is essentially the most complex This is my MVP, most complex expression that we could possibly represent in this language at this time. Because I'm not doing operators. This is the madness we have to deal with. So... do I just want those to be path expressions? I do path. Well... You know what? I'm going to not worry about it. So I have a feeling that all expression is just going to take care of all of this. And if instead of path, we do we have just a variable I'll call this find value, and this will take in a symbol ID. We have this find value. And the result of find value will be value. And we can have member, we'll just call it get member. And this will take in an expression and then another expression. Can I do this? Possibly. Can I possibly do this with my current cursor? No. My current parser is too cooked to be able to do this because it's the way that we enter into expressions doesn't allow for, yeah. What we want inside of the let statement is actually a match. Like a match definition or match declaration. But for now, I'm just gonna say symbol ID. now I don't need... Yeah. The vector of expressions option. Technically, if we arena allocated all of this, we'd be able to do, like, not a ton of memory allocations for all of this, but that's fine. I'm not going to worry about that. I do not want to worry about that while I'm trying to write it quickly. So here's our closure. So for the moment, we don't really have anything other than parameters, which are symbol IDs. Ooh. In the AST, is this? No, this is not the place where I figure out what the closure actually captures. It's iterating over this when we emit. When we actually emit our code. So we'll deal with that. So we have our parameters here, and then we have our body, just a box expression, which if we need a scope, we'll just define it with the scope. And when we call a function, we need to have the this is the thing that we're going to call, the expression that we're going to call, which in the case of this call, this is our expression. In the case of... Right. And this is all of our arguments for the expression. Then for objects, we just need a vector of symbol ID to expression. And then array, we just need a vector of expression. Did I leave anything out? I left out assignment expressions. This everything? Not quite. What else did I need here? Reassign existing variables, closure, variable capturing, branching, match expressions, looping, and array types. Okay, so I just need... How do I deal with match statements? Because if I do match statements, I need to be able to actually do, like, pattern matching. Which I don't currently have pattern matching. I would actually need to implement pattern matching for that to work. Now, it'd be really nice to have pattern matching working. Do I actually want to implement a match syntax? Like right now. At 9 p.m. when I want to go to bed in like 2 hours. Problem is, I've never implemented match syntax, so I don't know how hard it is to actually do that. Oh, you know what? Let's explore match statements. Because that's always something that I put off, but I feel like, unfortunately, I would... My goal of testing out, hey, do I like writing C with custom language? The answer becomes yes a lot quicker if I have match statements. So... have a pub struct, and this is just going to be a match. And the reason I'm putting these in structs is so that I can put spans on these later for better debugging. So, pub enum match kind, and the kind is match. Okay. So, what types of matching do I want to support? I want to be able to match against... So to give you guys an example of what we're kind of talking about here. This is called pattern syntax. That's actually, that's a better way to say it. I much prefer this being called pattern. we're gonna let this be a let pattern equal box expression. Yes. Yeah, so one of them is literals. We can match, like, this is when you mostly use matching is for variants like that. Now, I have not decided how we're going to handle tagged enums yet. So that, I don't know. I don't know how to deal with that. Slightly. There's no... With dynamically typed languages, I don't know how to deal with enums, because, like... For enums to work, you need static types. You need to predefine what the enum... all the variants of the enum could be. You need to define what all of those are. And then... after you define what all of those variants could be, I know static is better than a dynamic. That's why. So the idea that I'm working with right now, the idea that we're testing out is, what if you use a dynamic language to write a static language? And then you get all the benefits of a dynamic language for, like, static language writing, where the dynamic language becomes your metaprogramming layer, because you need dynamicness for metaprogramming to actually be, like, for the metaprogramming to be ergonomic, it must be dynamic. Rust has static macros, and they kind of suck to write. They can be really powerful, but they suck to write to the point where I just don't write them. I love using them, I don't like writing them because they suck to write. Unless you pull in third-party libraries, and it's ridiculous that I have to pull in third-party libraries to make Rust macros nice. But can't you have a meta-specific type instead of fully dynamic? This code runs once. Or at least it should run once. There's going to be no static validation on the dynamic language. So a runtime error of our dynamic language becomes a compile error, is the theory that I'm working with here. Runtime error of the dynamic language becomes a compile error. So with enums, I see the way that you would create a dynamic enum is, I guess you would just let them define their own tag, and then, like, if the content of the inside of that, like, if the data of the tag isn't what you expected, then you get a runtime error, is kind of what would happen there. But because I do want the language, like, so I want to use enums, typed unions, tagged unions, discriminated unions as our return values for, like, error checking and all of that, right? Which means I do need them. And do I need to, in advance, have these defined, because I'm thinking about if I'm trying to make these enums work at compile time and runtime, they need to work in this language, and they need to have black magic behind the scenes to transform them into the target language that we're emitting with this system. Therefore, if we're trying to emit them to a target language, that means that they need to have a definition stored that references every single variant that they could be. So I need to have basically a type system that doesn't exist for the dynamic language, but exists for the target language. We need that type system. And then we need each enum variant after it's created, that enum variant needs to be able to reference back to what definition was used to instantiate it. And that, like, trait of where it was instantiated from needs to be a runtime value instead of a value that is created during analysis of everything. So that brings me to the question of, are enums a type, native type of the dynamic language, or are they a structure of the dynamic language? Basically, this is the main thing I can't decide on. Inside of VM values, do I put enums as one of these values, or are enums just an object? This is also a problem I had when I was exploring this idea as a rendition of BrainScript before, was I could not decide, should enums exist as objects or not. So for our pattern matching syntax, we need enums must be a part of our syntax for the pattern matching. Do they need to be a runtime value to exist for the pattern matching syntax? What values does pattern matching work with? So let's look at how Rust does it, because that's basically what I'm copying. So there's the whole it's a bunch of fancy stuff they do here, which I'm not worrying about too much. I'm mostly worried about how destructuring. So when we destructure values using pattern matching like this, you put the type here, then you put the value here. So that's another question I have for myself. Are types something that exists as a different form of value? Or are types an expression, just something we build with the objects of the scripting language? So I guess it's not even enums that I'm confused about, it's just the concept of a type. Is a type a different type of value, or is a type an object? And because I want to mess with types, because I want to mess with types. Types should probably be objects in this system. So I need to define a structure of object that is a type. So if you've ever... The reason why I'm struggling with this is because in TypeScript, which, to be honest, TypeScript would probably be the language to write something like this in if you weren't going to write your own scripting system because you want to have pattern matching. In TypeScript, their interfaces are just a... Oh, what's the... I can't remember the name of it, but in type theory, there's a difference between defining variables by what the shape of the data is and defining variables by, like, just like, I've named this type this. And, like, what the shape of the data doesn't matter, it's just, like, the tag on it. So if you go off only shape of data, then suddenly pattern matching, like, might run into the problem of the name of the... Like, if you have two types that are the exact same structure, like, they're shaped the same way, they're named different things and they represent different things, but they're shaped the exact same way. Let's say you have, like, a vector 4, like a position, or like a vector like a position, and a color. And I guess color would, like, have RGB as its member values, not XYZ, but if you overlap those, they're the same shape. And, like, if we're pattern matching, we could confuse them. Unless I did... Oh, joy. And then you get into, like, oh, do I check the difference between these types by, like, by pointer value? Like, are these the same object? Then you get into the, like, comparison by structure or comparison by, like, value. Comparison by structure, comparison by value. My siblings are being loud right now. Which, if you've ever in JavaScript had to, like, learn the difference between double equals and triple equals, that's kind of the problem I'm stressing about right now, is, like, do you compare structures by if they have the same values, they are the same structure, or do you compare them by, like, if they actually are the same object in memory, instead of... Yeah... I guess I just have to have different equality things for that, but I think equals, like the equals operator, that should always be a by value comparison, not by location comparison. But for types, I think I can get around my concerns of... Yeah. So, types, I have decided. Finally come to a conclusion. Types are objects that are defined by the runtime. I think I'm going to add an extra property to virtual machine object. So if I go to object here, we're going to allow structures to be locked. So my main issue with having types as objects, that means after you define a type, what if I'm writing, like, I'm going like metadata, like, or metaprogramming wizard, and let's say someone other than me is eventually using the system, and they decide for the haha funny to change the string type halfway through the program. Like, they literally say string dot whatever equals whatever. Like, they just literally change the definition of the type halfway through the program running. So what I'm going to do is I'm going to define a intrinsic lock function, which will set this boolean on the object to true. If an object is locked, it may not be mutated. Including to be unlocked. It may not be mutated, and it may not be unlocked once locked. And we'll put some restrictions on this, like the local stack object won't be able to be locked, the global object won't be able to be locked, because otherwise you'd kind of break the virtual machine completely. Or I just let people do it, and then their code doesn't compile, because suddenly the VM doesn't run because you locked the global object. In fact, I think that's what I'm going to do. Because it just breaks the program to do that, I'm just going to let people do that because it would just break right away, and it's a compile error, so it's fine. If an object is locked, it may not be mutated, and it may not be unlocked once locked. Okay, now. That makes me happy. And now I can have types. Types will be... And typing in the big 2026, indeed. Also, dude, genuinely, what would be the fun of watching me stream myself vibe coding? I don't think that would be very fun. Like, I find vibe coding kind of boring. So, like, why would people want to even watch me vibe code? I would just be, like, cussing out the chatbot for doing it wrong. Which might be funny, but I wouldn't find it very enjoyable, and I don't think it would be enjoyable to watch. Like, occasionally I'll get really desperate, and I will, like, use LLM as, like, a search engine on stream, or just for the fun of it. Like, I do have, like, a, like, vibe coding thing here. But it uses a local LM, and it's, like, super slow, so it's, like, it just doesn't work when I'm streaming. Making language? Yes, we are making a language right now. It's kind of like, it's slightly a copy of Rust. It's a copy of Rust syntax. It's going to have very similar behavior to Lua, and we're going to use it to output C code that will actually compile and run. So, very strange idea that kind of has been done, but with Lua instead of with a custom language. But yeah, it's just something that I want to test out because it's an idea I've had for like a year, and I want to see how it works. How does it actually feel? But now I'm getting into like the weeds of making a language instead of using the language to write code. Well, see, the thing is, the LLMs make devs less good because it makes them fall out of practice, if that makes sense. So it's less so it's actively like it's not actively sabotaging a dev. It's more so the dev is no longer coding, so they forget how to code, if that makes sense. Like in the same way, if you like walked away and didn't code in a year, it's similar to that. But if you got into the habit of anytime your brain went, okay, I need to write this code, instead you tell something else to do it than writing it. So then you get in the loop of like, have you ever had like you buy some tool, or let's say technology gets better in some way, and then you stop doing something the old harder way, and now you're just using the easy way all the time, and like you reflexively reach for that easy way every single time to the point where like the harder thing becomes physically like harder to do. That's what happens to it. uh I wouldn't even say that LMs are better at code generation, because a lot of times, shall we say, they favor lines of code rather than simplicity of the program. And if you're actually a good dev, fun fact, less lines of code is better. Okay. So our match statement here is going to be a vec of pattern to a vec of pattern to expression. We also need the condition. We're also gonna have a while. And I think this might be at the very base level every single grammatical concept we need, because I'm ignoring most operators at the moment, because we can substitute intrinsic functions, which is how I'm going to define operators behind the scenes, and I don't want to have to deal with parsing for operators, so we're just not doing them. All operators are our calls. It's the Lisp method. So while the first expression returns a truthy value, fun fact, truthy is actually the correct term for that. Returns a truthy value because it's not a boolean, so it's not true. It could also be like, hey, is this object an object? While the first expression returns a truthy value, run the expression. The second. If the expression matches one of the patterns, execute its paired expression. So with the knowledge that our patterns are just going to be, well, with the knowledge that our types are just going to be predefined by the runtime itself, we'll just know that the patterns will be expecting objects constructed in that fashion. And eventually I'll have to create syntax to define types, if that makes sense. Like, eventually instead of object, I'll have to do structure, and that will define, like, here's a structure type. Not a value, but a... I guess yes, a value, but... This will be really interesting to see how this ends up feeling, because I'm starting to actually see the vision now. Let's bring expected token from here to, actually, we'll bring the entirety of parse error into the parser. Now pattern kind. We will have one type of pattern kind, and that will be binding. Synthwave. Does that have to... No, because we can do object through the... Ooh. So how do I do the difference? How do I... pattern match the difference between a binding and a type. If a type is a runtime value, how do I tell my parser the difference between, hey, this is just a wildcard, we want to expose the value at this point in the pattern, we want to expose that as a variable to the branch that you're about to walk down. How do we expose the difference between that and a type, which is also just like the same syntax? Both of those are just a raw identifier. So do I want to add extra syntax to the binding? Or do I want to add extra syntax to the... Do I want to add extra syntax to the type? Ideally neither, because we're using pattern matching for getting members. Wait a second. Wait a second. We can have it. We can have it be position dependent. So in this example, you can see let point, they say let point xy equals p. Now in my system, my parser is types. Are types part of the pattern matching syntax? Or are they not? They're for enums. But I need to decide how my pattern matching syntax works. When I do care about the appearance of static typing. I just had a realization. No, that doesn't work. Because for that to work... Now, so I was thinking about back to when I was trying to write this sort of system for BrainScript, and I had the idea that, like, oh, match expressions or if statements, they can just take a function that returns an optional, and if that optional is sum, that means the match succeeded, and now you have to bind the variables that are returned from that. But all that does honestly seem to make a lot of sense for this situation. The syntax would not be ideal. Could I make the syntax ideal? Would I make the syntax? So if we say let who equal struct a int b float, like that, and let's say that I32 Wait a second. Might have just solved... I might have just solved my function calling problem. This is an old idea I had. for a different... For a rendition of BrainScript, there was this idea. I mean, it was for different renditions of like, okay, what's my common function calling convention? And then eventually I just settle on like, I'll just implement every single CABI. But what if what we pass into every... Honestly, I was just cooking with this entire line. So I don't want to write I like that, but okay. I'm cooking with this idea here. Okay. So I think this solves my function calling problems. Potentially makes the scripting language a little bit slower to execute, but I don't care about that. It's just runs at compile time. But if where should I put this right in the IR? What if, hear me out, instead of variable arguments, everything is getting less chaotic. I'm figuring stuff out. We're figuring stuff out. Yeah. Yeah. Anyways. The idea I have now that makes parsing a lot easier than the route that I was just about to go is what if instead of the args being passed on the stack, what if instead we passed arguments as an object? Now, all of a sudden, I don't have to worry about... Still make... Actually... This works in the virtual machine as well. If I don't do the, you know, common stack machine thing of... If I don't use the stack machine as a stack machine, it makes things easier. The route I'm going to go with for this. And I'm going to add square bracket calling syntax. And if you do an expression and then square brackets, that means all this callable function with this set of... These are our arguments, and we're manually naming our arguments. And inside of functions, we will have an arguments object that will be directly exposed. Like in here, I'll be able to do args A, args B, just like that. So with parentheses, we'll just call the object solves all my problems doing it that way. Okay. I don't have to write an AST anymore. I'll keep it around, but for the idea of it, I'm gonna just click undo until we get back to where we were. Okay, yeah, building AI from scratch, that sounds a lot cooler than just like kind of giving up and like surrendering yourself to AI, because that did sound kind of depressing, but I didn't want to say anything about that. Creating AI, that sounds a lot cooler. Here. So I should probably copy, well, actually make like parse construct object. That. Yeah, I've been tempted at some points to be like, would I be able to write a transformer from scratch? But I'm like, I'm already writing game engines and coding languages from scratch. I don't need to add more hobbies to the list. Say parse construct object context like that. Where is my atom parsing? Here it is. So instead of doing this, we're gonna do oh, I already have that comment here. But here, instead of all the arg count stuff, we could still we will do context is next, token kind, and then open brace like that, and then I do self parse construct object. So we construct an object and then we call indirect. Here, if open param, we don't need to do arg counts anymore. It does need to account for 0 arguments. Currently, if it doesn't get an expression, how am I doing it for construct object? Next, if ident how do we account for 0 oh, here's what we can do. You can actually say if context is if context is net, or actually first. First, we need to construct our argument object. Which I'm gonna account for if we call functions with this syntax here, this syntax right here, we're manually setting the variable names of our arguments. If we call functions with this syntax here, we need to implicitly set the values of the arguments. Unless I get funny. Unless I do funny. I could do funny. I could let get member accept int values. And if get member accepts int values, then it could be, yeah. String member label or int member index. It's so cursed. If I do that, function definitions like this, A can get transformed into args 0, and this can be transformed into args 1, because we're already implicitly constructing an object to hold our arguments and then grabbing values directly from that, so there's no extra performance cost to doing it that way. Oh joy, I just realized object technically doesn't need to be custom syntax, because it could just be a function call that it could just be a function call create generic object. I'm gonna keep the custom syntax for it though, because parsing it is a lot easier if it is custom syntax. But it looks like I'm not... Oh, here we go. Expect ident. I don't have a way to expect multiple. I'm going to implement into iterator where the item is result token So if we could expect any of a number of different tokens, I need this to be a we're gonna refactor this very slightly. What are we gonna call this? This needs to be called expected grammar error. This needs to be expected token error. There we go. And then this can be expected token. Of kind, and then this will be IR token or this expects an exact token, and then this will expect an ident, and then this will expect a literal. And now that I have this differentiation, I no longer have to have these three different functions for each one of these. Instead, I can say expected token, and then I can match on the expected. And if this is of token kind, I can do this. on. There we go. That's more like it. Then for the ident, I can just throw this in. Xkind equals kind like that. And then for literal, just copy. Those shouldn't have been result types to begin with. And then all of a sudden, next if can become just expected token. It can we can say self is next expected. Like that, and now this works. Next if works for all token types now. And now we don't have to do these next if idents. And expect can be next if expected. Siblings are being loud again. Do next if it's just expected like that. And here, can I copy clone this? No, I can't because it's not, tokens aren't interned. It would actually make it easier. I could derive copy for that. But I'm not willing to refactor my parser to actually intern strings yet. No. The viewer bot guy didn't get automated this time. It was working for 2 days. Go, and now expected should implement to string. Now expected ident and expected literal aren't needed anymore. Now, in here, when I do expect any, I could do options of instead of doing this weird, like, passing functions into a list that I was going to do, instead I could do expected token, list of expected token, and then for option in options into iterator, or I think I can just do for. Actually, we do error expected token error expected at span, I guess next span. Then we expected. Ooh. It assumes the value. So do I want to put them in a vector just so that the error works cleanly? I guess. Then unexpected options error map. Is this a string? It is a vector of strings, so we can map to string select. Then here no, pick the type, right? Back here since I forgot what the syntax is. Or is it just that? That work? No. Doesn't like that all of a sudden for some reason. So then for option in options, for option in options, we want to do if let okay token equal option self. Actually, I'm gonna say next if, that way we're not going through. There we go. So now we have a clean, internal of the thing is clean, but now we have a clean way to expect multiple different variations of a token and give clean error messages for them. These are all annoyed because I just broke the entire parser. Yeah. this. Here, no. No. Yes. 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 Okay. And now I just need to go through. That was a lot less than I expected it to be. Oh, right, because I also have is next to fix. I didn't fix the next if functions. Wait, did I? No, they're not showing. I'm not able to navigate to them, but I would assume I broke them. I didn't delete them, actually. Yeah. Oh, nope, there it is. Let's fix all of the only next if now? I don't know. But I'm gonna do this again, so if next say next if is going to be equal to context next if token find like that. Okay, and then we're gonna do this again. If ident I'd go through all that trouble only for that to be the only instance of that. Yeah. Anyways. Dang it. I named it wrong. Fancy description for a compiler. Well, technically what I am doing is writing like a new language that is explicitly a language that you write that writes another language. Like you'll have access to the knowledge of the output language, if that makes sense. Metaprogramming. Lots of metaprogramming. Metaprogramming as a language. Why didn't you just pick Rust for this mission? Because Rust is not as ergonomic as I want it to be for what I want to do. In fact, Rust would get in the way a ton for that specifically. Like a massive amount. And I say that as somebody who really likes Rust. It is not the tool for that job. Look at Rust, I got irritated on that. It's a very ergonomic language if you do stuff the way that it wants you to. I've done enough Rust programming that I want something slightly different. I agree with so much that Rust does. There's some parts of it I would like to be better. I don't know, I have a hard time explaining it. Basically, I'm not anti-Rust, but it doesn't serve the needs of exactly what I'm going for. But it is a very good language. It just mindlessly did that same thing. But I will say, if you're trying to sympathize with me by saying, yeah, no, screw Rust. No, I do like Rust. Even though I'm not using Rust. Well, actually, I am using Rust to write the language that I'm going to be using instead of Rust. So I am still using Rust. Okay, now that I have all of that done, I can now what was I gonna do? I can't even remember what I was gonna use that expect syntax for anymore. I'm stupid. Okay, so we parse expression right. context is next. I can't even remember what I was planning to do. With that massive refactor. I got the one utility function I wanted, but I can't remember the exact situation that prompted me to do that. Yeah. This next kind, token kind. Not ident. Close parenthesis. If this is a closed parenthesis, I want to do basically nothing. Oh, can I do context? Push, pop, where op, construct object 0 to create an empty object. I probably can. Otherwise, we'll actually look for members. So we're gonna parse expression. I just realized I didn't fix my problem, which is that problem is that at compile time, I don't know what function I'm calling, because this is a dynamically typed language. We don't know how many arguments there are, what the argument names are, so I can't construct a object with arg names. So instead, what do I construct instead? Let's just do construct array instead, and then, yeah, that works. So if we construct an object, we can also construct array. So we're just, yeah, we have arrays now. And I'm going to update my definition of call indirect, that this can be an object args or array args. And if we call a function with an array arguments, Yeah, if we call a function with an array of arguments, our runtime will automatically map that array onto known array values, basically. So here it constructs an object, because that will have the least overhead, I think. Actually, constructing an array would be less overhead. We parse an expression, arg count plus equals 1, and then construct an array with that arg count. Then the rest of this is correct. It's fine. It's good. Then I need to make sure this is working, basically. By updating the VM to do oh wait, did I? Okay, yeah. Now in push function stack frame. We have an arg scope. Yeah, instead of all of this, we just need to do args value. I'm gonna call this root scope instead. Better named. Arg count is now, we don't care about the arg count. And we don't need to care about going in reverse from parameters popping off the stack. Instead, we need to do if let value don't have value array yet. technically. Now it's fine. Okay, so if let value array equals args value, we want to do for parameter say let args is equal to self this is the VM, right? No. Oh, I do have an arrays. Vec value. Arrays. ID. And then for each one of these parameters, we're going to set a member parameter, which is an ID, and then the value that we're going to set it to is args I. And in here, we're going to say if args length less than function def params length, then we need to return error, runtime error, this whole deal. Runtime error kind, incorrect argument count expected, args length got func def params length. Incorrect. This one needs to be here, and this one needs to be here. There we go, and I think there's probably a cleaner way to do this. Much cleaner way to do this. Bunch of iterator magic and all that. Else root scope if let value, else if let value, object, now this is enforced by the error. Type error. Expected. Found. This isn't error? No. There we go. And then root scope equals self VM objects. There we go. That is a massive jumble of pattern matching, but correctly error checks and all of that, and correctly exposes arguments. This run? No. Instructor Ray is not covered. Array equals with capacity, array, push, self stack. Or I could append split off do? Splits the collection into two at the given index. I wouldn't even need to stack split off at self stack length minus item out. Is it that easy? Self VM arrays push array values. There we go. We now have arrays implemented. You can't read the values of the arrays because I haven't implemented an index operator, but we have arrays now, like at runtime, maybe. Match value array not covered in VMRS 195. Source span not found in this. Okay, that's all parser type stuff. Can I just remove parser? $71. Oh. Failed function loading error. Unexpected comment. But my Lexer accounted for comments. Does it? Yeah. Unexpected. Oh, it's saying unexpected comment, not expect. I see, so this is actually, it's actually accounting for it. That's a problem. I'll deal with that a different time. Structured object or array found int. Immediately fails. Now executing anything? Oh. Right. This is because I have to seed values. I'm just gonna pass a reference to the global object. It's fine. Did callable found array. Oh, okay, yep. This is because we're currently trying to find a callable where we find arguments. It's easy. We'll just update this to for external functions. I guess now we need to also pass in. Do we need to pass in? Do we give it its own function context? We should. We should give its own. We should give it its own stack frame, so that we can do stack traces properly. But because I'm lazy, I'm just gonna do this. Now fix main to account for the fact that now to pass in value here, let that shouldn't be the way that I do it, but that fixes that. This, do that. There we go. Now, good run. Int 5, yes. So this runs. Refactor functions to take objects as arguments. And that's actually huge for ease of getting things working. Now, let me actually check. Is my named, like, it does? That worked first try? It did work first try. Object found int. Found int? What? Why is that the error? This should be calling this like a function. See, this should be a label. Index 3. 3. What do I do if get member isn't found? Yeah, I just straight up unwrap or value nothing. So this should be returning value nothing here, not nothing. Okay, so I can find value, int 3. Oh, wait. It's because of my workarounds. Since it's not finding B in the local stack, it's finding B defined in the global stack. So what if I name this like B1 and this B1 that breaks the chain? But here, oh, that's what's happening. Right here, the the parameter is overriding this local variable. Oh, that would, yeah, okay. So I'm gonna to do for myself. To do need to make args a member of the scope, not the scope, not the scope. Because currently the arguments are the base layer scope. I kind of just no-brained that. Okay, well, it's 11 p.m. So actually I have 10 minutes. I can fix this real fast before going to bed. When we push function stack frame, we're gonna call this args values, and arg values, register object arg values, and then this gives me my arg values structure. Ooh, and this also filters it so the array is never exposed to the caller. It's just args. That works. And then here in the stack frame, function stack frame, here I want to screw it. I'll just directly store the object right here. Args. No, they can reference it. Args equals option. args is an option argument ID for if we have arguments. Currently it's not optional, so I'm gonna make this not optional. Now, error stack frame. Be getting an error somewhere. Yeah, for stack frame. So our args values, and then root scope needs to be where it is. Here it is. This is root scope. And I'm stupid. It's not actually root scope. We're not putting this args on. Here. We want it to be a variable accessible to the. I don't know. Actually, I'm going to keep it as an easy lookupable value, but I am going to root scope here from members, and then we're going to add another object member. Come on, give me the thing. Self-VM, intern, symbol. Symbol we want to intern is args. Value, object. Ugh. And that just saves the little bit of saves a little bit of computation where we'd have to manually find the scope object of the function and check its args member. So, let's see. Pickups. Let's grab some water. Okay, so instead of, yeah. Now whenever we do find value, we want to, instead of iterating the stack frame in reverse, the first thing that we want to check is I'm gonna throw this back in here. So I can do this. So I can do if args object equals self VM objects self function stack frame here I can do frame args. This is a object. I will reference it if let some arg value equal args object get member value label. Okay, there we go. Check the args object, then local scope objects in reverse, then implicitly check global object. Then we have this here, that is our workaround, until that's working. So theoretically, I just fixed this error. Dang, I didn't fix that error. Because do I want to filter out parameters that aren't explicitly named? Not really, no. This is a very niche bug that I'm going to run into a lot. But hey, at least now I can manually access my arg values. Say args.that. Well, I think, yeah, that's all for today. So how much of our to-do list did we get done? Nope. 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 Didn't get any of the to-do list done. But I did solve this problem of like what are enums and all of that, and how all of that works. And I am happy with the architecture stuff got done. It's sad that like I spent half the stream writing a parser that we ended up not using, but it is good because I figured out better syntax for certain things and whatnot. Anyways, so I think I'm going to end the stream there and get to sleep, so I'm not dead for job in the morning. But yeah, thank you to everybody for sticking around, and I will see you next time. Bye.